if your equation is going to be, so we go with this one first, okay? So this is going to be another example. Have, okay, example. It is going to be a linear equation with the initial condition. All this is initial value problem. So we want to find the solve. For each case that we consider, we're going to have one of these. So one of them would give it to us. So the initial value problem. And this is the equation. Sometimes in application type, especially in physics, we use t rather than the x. So I just write it down, so don't be surprised. If you give me something like ty prime, okay, t prime plus 2y equal to the sine of t. The sine of t, and initial condition is that y of the pi half, y half the pi half is equal to 1, and t is time, so it's going to be positive. Okay? So you have the initial condition, so you solve it, and then you find the constant c. As you can see, it's linear, but it's not in standard form. The first thing to do is you always should have a monic, we call it. The coefficient of y prime must be 1. So first thing to do, you have to divide it by t. So the solution, first, we are going to change it to the standard form by dividing. Divide by the variable, independent variable is t rather than the x. Dividing by t or divide by t. That will give us y prime plus 2 over t y, and this is going to be sine t over t. Now this is a standard, this is a standard linear equation because you have the y prime, you see y prime, and the coefficient 1, y, the coefficient is 2 over 2, and on the other side we get sine t over 2. So it's a linear with these conditions. The conditions are going to be p of t this time. It's going to be 2 over t, and the q of t is going to be sine t over t. Okay, so we have to find the mu, that integrating factor. We go with the px dx first. So we're going to find what is integral of the px, in this case pt dt. Okay, pt dt. So p of t is 2 over t. So 2 over t dt. Now that you put this 2 out, and that gives you ln t, 2 ln t. T is positive number, so we don't need to have the absolute value. Okay, so that's going to be integral of pt dt. Now we are ready to create the mu. So mu is e to the integral of the px dx, pt dt. So this is going to be e to the 2 ln of t. Now we move the t up. So this is going to be e to the ln of t squared. Now you know that e and ln, they are inverse of each other. They will cancel out if you like. So we get t squared. So mu, or mu of t, is going to be equal to the t squared. So your integrating factor is t squared. Any question? Okay. Now go with the formula and get it. The formula, remember, solution is going to be y equal to the 1 over mu integral of, in this case, q times mu. It's going to be q of t mu and the dt. Substitute, integrate. So if you substitute, that's going to be 1 over t squared. 1 over t squared integral of q of t is sine t over t. Multiplied by t squared dt. One of the t's would cancel out. Okay, one of the t would cancel out. So you have the mu y is equal to the 1 over t squared integral of the t sine t dt. Okay, you must use integration by parts because you have the power of the t over here. So we use that top-layering method if you like, those shortcut that are top-layering. Okay, so if you want to use the shortcut to find this integral, t sine t dt, we're going to do it. Remember, this is going to be a table, and this is going to be the sine part. Differentiate over here and integrate over here. It's going to be u dv if you like. So the sign start with the positive sign. Take the u to be t dv if you like. The other part's going to be sine t. And you continue on the first part, differentiate, second part, integrate to get the 0 here. So that's a positive, then the next one's going to be negative. Derivative of a t would be 1. Integral of a sine t. Integral of a sine t would be, okay, negative cosine t. We continue, this negative sign would be positive. Okay, derivative of 1 would be 0, but integral of a cosine would be just sine. So that gives you negative sine t. Now we're going to collect the result with this cross multiplication type. So that we tell you that this is it. But the fact that the integral of t sine t dt is going to be equal to the first part, it's going to be negative t cosine of t. Okay, minus, it's going to be minus negative sine t. It's the last part, but that's the constant c. Okay, so negative here would be positive, and you bring it up here to get the final answer. So this is the final answer. Y equal to the 1 over t squared times it by negative t cosine of t. This is negative would be positive plus sine t plus c. Okay, so that would be the general solution. You can multiply t squared inside, simplify it, and then you have to find the c. Okay, so if you multiply inside, so it's going to be negative. The first one would be cosine of t over t. It's one of these t's will cancel out. Second one is going to be plus sine t over t squared. The last part would be c over t squared. Of course, this is the general solution. Okay, so that is going to be the general solution. Any question? And you're not done because you have to initial value. Yes.
Can you move it down a little bit?
One, done.
No.
Or up. That one is going to be up. That's right.
Thank you.
One. And you're not done, we have to find the c. So you have the fact that the y of pi half is equal to 1. So replace the t by pi half and the y by 1. The sine of the pi half would be 1, the cosine of the pi half would be 0, and we can quickly find it. Okay, just write it down and go to the next page and finish it. Okay, so you're not done. You're not done because you have to find the constancy. Any question? So this is the so you have the initial condition. So apply the initial condition. The initial condition is that y of the pi half is equal to 1. So this means you are going to replace. So replace the t by pi half, and then y by 1. That's in the equation. So equation start with the 1 equal to. Okay, 1 equal to, it was a negative cosine, it's going to be negative cosine of pi half divided by t, which is the pi half. This would be 0, plus it was sine of t. It was sine of t over t squared. So that gives you sine of the pi half over t squared, which is the pi half squared. Okay, plus c over t squared. C over t squared, and the t squared is again pi half squared. Okay, the cosine of the pi half would be 0. Sine of the pi half would be 1. This is how we're going to simplify. It's going to be 1 equal to. Okay, so the first one would disappear. So the second one is going to be 1 over squared pi squared 4. And this is going to be c, and you get a pi squared. Okay, multiply both sides by pi squared 4. So that gives you pi squared quarters. This is going to be 1 plus c. So your c would be pi squared 4 minus 1. Okay, go back, substitute the original one, the general solution to get this particular solution. So y would be negative, go back to the original one, negative cosine t over t, and plus sine t over t squared, plus c over, okay, t squared. So it's going to be pi squared 4 minus 1 over t squared. So this is going to be the solution to the initial value problem. Okay, any question? So we're done with the linear equation. It's a very popular equation. So we get one of them in your quiz and on the test. Now there are a variation of this linear equation. We change it to different formats. And the equation seems to be linear, but sometimes if you do specific substitution, you change it to the linear equation. There are two famous ones in application in physics. One of them is called Bernoulli equation. The other one is called Riccati equation. Okay, we can talk about both of them at the same time, but now we talk about Bernoulli one, which is straightforward. Riccati is a little bit more involved. Riccati one is used even in several variables. It's used in some phenomena in physics. That would be much more involved. But we talk about, because in your book, they classify this equation as solving the differential equation by substitution. Now, one section, they give you substitution. The more general one is that this is just a popular method in differential equation, that converting the given equation into the linear. There are quite a lot of this type of equation. These two are famous. So I talk about the Bernoulli one now, then I talk about the Riccati one, then get to the, as soon as we are going to be prepared for the test one. So we get one each, one from each. Okay, there is a history about this one. Different project that we can talk about it later. And we have a couple of people that do this on a contract. One of them is on the Riccati equations. Then I post the idea of, and I modify the syllabus for the honors, so we can have a look if you like, okay, for yourself to know. Now, what is the Bernoulli equation? Okay, this is it. So now we just change the place, if you like. We like this one to have it in this format rather than. Just want to emphasize that this is a linear equation. Okay. Bernoulli's equation. That's the one. You know that Bernoulli's families are very popular. There are several brothers, and they have done quite a lot in mathematics. So if you want to say Bernoulli equation, you may say, which one is it? Is it Jacob? Okay, the other one. So, and there is also a Bernoulli equation in physics, which is different from this equation. Okay, some people thinks that there is a relationship between the Bernoulli differential equation and the other one is it's something about the heat, fluid, etc. In search on internet, we see quite different things. So it's not. This Bernoulli differential equation would have some application, but it's mostly for fun if you compare it with the other ones. Okay, so no connection between these two at all. Okay, so what is the situation we're going to have? Remember, linear equation is what? Y prime plus pxy equal to the q of x. Bernoulli equation is not equal to the q of x. It's equal to the q of x times power of y. Q of x, y squared, y to the fifth, y to the sixth, okay? So on the one side is typically linear, but on the other side is not, because you should have only q of x. You cannot have q of x and a function of y at the same time. But if you have a y over there, so it's a Bernoulli. So quickly you can identify it. Although, on the test and the quiz, we ask you to solve the Bernoulli equation, okay? So this is the one, then I'll tell you that you can even extend this one to much more format, but sometimes we give that one as a question, but we are not going to do it, but we let you know. Okay, so this is it, the differential equation of this form. Okay, the differential equation, of the form. That's the form. You see, look at this one. This is y prime plus pxy as we know it. And this is equal to the q of x. But there is an extra factor. That extra factor is a power of y. Something like y to the n. See, this is called Bernoulli equation. So differential equation of the form, of course, where n is a number, and it's going to be just any number. Any number is going to be called, it's going to be called Bernoulli equation. That's it. Bernoulli or Bernoulli's equation. So it's very easy to identify Bernoulli equation.
N equals 0 for that or no?
Yeah. In fact, I'm going to ask. If n equal to the 0, what's going to be the result?
It's just going to be a linear
It's
equation.
just be linear. In fact, if n equal to 1 as well, if n equal to 1, that it's going to be qx times y. We can put it to the other side. You have pxy here, and then we get the qxy factor of the y. So that would be easy equation. You can call it linear. You can call it equation with a separable variable.
And can also be negative, or can only.
And yes, can be negative, yeah. You can have something like qx divided by y squared. Okay, so it would be again the same thing. So that's it, that's the case. The case after 0 and n was equal to 1, if you go read the history of Bernoulli equation, they will discuss, by different people. They study this one. Got a large, great history of how they did it. It seems to be a very easy equation, right? It was popular. So let's write down this one. If n is equal to the 0, y to the 0 would be just 1, so the equation is linear. Or if n is equal to 1, then we can say that the equation is linear. The equation is simply linear. Okay, so we assume that n is, suppose that n is not equal to the 0 and 1. Because if it's going to be the case, you got it. Any questions? Now we're going to solve it in general. We say in order to solve it in general, this is the extra term that we have over here. If that extra term was not over there, then that equation was linear. So divide both sides by y to the n. Okay, we're going to prove the method, then you can use it. But you have to do this one when you do the problem for each problem. Okay, so to solve the equation, the Bernoulli equation. Okay, divide both sides.
Sir, could you move the?
Okay. Divide both sides. Divide both sides. Divide both sides by y to the n. Remember that this is equivalent of multiplying both sides by y to the negative n. Or multiply by y to the negative n. Because we want to simplify it, so y to the negative n would be easier. So what's going to be the result of the equation? This is it. So this would be y to the negative n, y prime. Yeah, and this is going to be p to the x, if you like, y to the negative n, and this is going to be y. And on the other side, it will be cancelled out. So we get the qx. Okay, so this is y to the negative n, and this is y to the first power. You add the power together. So the result of the equation would be y to the negative n, y prime as p of x times the y to the 1 minus n. 1 minus n equal to the q of x. So that would be the result of the equation. Yes.
I thought you couldn't have like a y next to a y prime. Oh, because it's to the negative at n. Is that only for a linear equation?
Yeah, that's fine. Yeah, that's for the linear equation. So that's the purpose. As you said, we cannot have y to the negative n times y prime. So what we're going to do, you see this is going to be, we are going to use a substitution here to change it into the linear. It's not going to be linear respect to the y and x, as you can see. But we are going to make it a linear respect to something else, respect to the z and x. Then we solve. Now how are we going to do it? And that's it. You see this part over here? Take this one to be z. If you take this one to be z, okay, so suppose z is equal to y to the 1 minus n. And if I take a z to be equal to the y to the 1 minus n, what's going to be z prime?
N's a constant.
Z prime,
So
Minus n.
bring the power down,
y,
1 minus n,
yes, y to the
y to
negative
the
n. Just subtract.
1 minus n, minus 1.
So it's just negative
Okay,
n.
it's going to be y to the negative n. Of course, you know, simplistic differentiation. Times y prime. Times y prime. Okay, so I differentiate both sides. Use the chain rule because y is a function of x. So the power rule, you bring the 1 over n down. It's going to be 1 over n. Okay, 1 over n. Y to the y minus n, you reduce the power by 1 unit. 1 minus n minus 1. So 1 and 1 will cancel out. You get y to the n. Of course, times the y prime. Times y prime. Okay, so what we are going to do now, extra job. Drop the second one. Keep this one. Keep this one for the z. But from the second one, solve for what? Solve for y to the negative n y prime. This means you divide by what? Divide by 1 over, okay, 1 minus n. So what is going to be y to the negative n? Y prime, what is c prime, divided by 1 minus n. Okay. Now go back to this equation. Go back to this equation and substitute. What's going to be the result now? You see, y to the negative n y prime would be what? Would be z prime over 1 minus n. So that give you z prime 1 minus n. Okay, that's the case. That's px times y to the 1 minus n. That is going to be z. It's going to be plus px times z equal to the qx. Okay. Now let's multiply both sides by 1 minus n to get rid of this number here. So if you multiply both sides, by 1 minus n, so what's going to be the result now? Result would be z prime. Okay, z prime plus. Okay, z prime plus y minus n. It's going to be plus 1 minus n. Okay, px z. And this is going to be simply y minus n times qx. Look at this equation that we got. You see, this equation is linear. It's linear with respect to the z and x, of course. You see, you replace it's like replacing y by the y prime. So it's a linear, you can solve it. Of course, to solve this equation, your solution would be z equal to the 1 over mu integral of e to the px dx, z. When you're done, you come back and you substitute for z. You substitute for z and you can solve for y and get the result of your equation. Okay, so that's the idea of solving the Bernoulli equation. You have to do it when you some people memorize this last formula, but for each problem, exactly you follow this, this method. You change it to the linear equation, and then of course the linear equation can be solved, okay? So if you call this one a star is going to be a linear equation. Okay, a linear equation in terms of what? A linear equation with respect to the, of course, z and x. Z and x. So when you write your formula, you're going to be careful not to miss it. Okay, that's how we solve the Bernoulli equation. Very nice equation. And the technique is very nice, okay? And I used to give you something more than this one, sometimes I refer to it. I don't know what we change it to those projects that we're going to have. You see, this is not surprising. You can even generalize the solution of the linear equation for yourself, okay, and create something new. Something new is going to be, you see, your equation is always what? Y prime plus pxy equal to the qx. So instead of y prime, you can change it to the function of y. You can call it f of y prime. And then f of y, in that case, it would be like the last part that we did over here. So the type of the equation that you can do a substitution to change it to the z prime and z can be changed into the linear equation. Those equations are going to be called a linear equation with respect to a function of y. And you can, we can have various examples. But for our procedure, we just stay with the. Okay, any question? So you have to go through this procedure, nothing to memorize for each part. It takes a little bit of time because you have to convert to the linear first, then you have to solve the linear. Okay, you solve the linear for z, then you come back at the end and you have to do the substitution to get the y equal to the z equal to the y minus, okay, y to the 1 minus. Okay, so that's it, let's do it. There are a number of these. Okay, you have 5, I think, in your practice one. Next one, and you will see one of them. One of those 6 questions on this comic quiz, and your next test is going to be Bernoulli equation. Straightforward one. Okay, so there we are. Check. See what is going to be special about this equation. So I'd like you to solve each Bernoulli equation. solve each Bernoulli okay, that's it, Bernoulli's equation. First one is this one, y prime plus 1 over x y is equal to the x y squared. As we talk about it, the part to the left is linear, like the linear. But the part to the right, you should have only q of x. You have an extra factor. That extra factor is a function of y, or power of y. So this is what you have to get rid of. That's it. So quickly, step one. You divide by y squared, or you multiply by y to the negative 2. Okay? So this is going to be the solution. You are going to divide by y squared. Okay, which is the same as or multiply by y to the negative 2. Okay, carefully multiply it. So this is it. This is going to be y to the negative 2, y prime. That's a 1 over x. This is y times y to the negative 2. On the other side, you get the x, because you remove the y squared right away. Now y times y to the negative 2 would be y to the negative 1. So that gives you y squared, y prime. That's 1 over x, y to the negative 1, equal to the x. So whatever you got over here, this is the one that we are going to call it z. Yes,
So y to the negative 2. Next step.
y to the negative 2, yes, thank you. Okay, so you take the z to be y to the negative 1, and you find the z. So that's it. Z is equal to the y to the negative 1. Differentiated z prime is equal to, bring the power down, it's going to be negative y to the negative 1 minus 1. Negative 2 times the y prime. It's almost what you like, but there is a negative sign here. So you are going to solve it for y to the negative 2, y prime. It's going to be negative z prime. This negative is very important. Make sure you don't miss it. Okay, now go back and substitute to get your resulted equation. Okay, so this would be the result. So that gives us a negative z prime. That's 1 over x z equal to the x. This must be a linear equation in terms of the z and the x. You know that the coefficient must be 1. So you have to multiply by negative 1 to make it linear. Okay, so multiply both sides by a negative 1. So that gives you z prime minus 1 over x z equal to the negative x. This is the linear equation, okay? It's a linear equation, so it is, just for your information, it's a linear equation, a linear equation with, now go to the mode of the solving the linear equation. So it's going to be linear equation with p of x equal to the negative 1 over x, and the q of x equal to the negative x. So you have to find the mu first. So you work on the formula. Yes.
When you transfer like the negative 1 in front of the x to the other side of the equation, wouldn't z prime also be negative, or?
Because the z prime, you get already negative z prime. So we change it to the positive.
Oh, okay. From the previous. Got it.
Okay, so go for it from now on, just solving the linear equation. Find the integral of px dx. Integral of px dx. Okay, it's going to be equal to the integral of negative 1 over x dx. It's going to be negative x Okay, we don't have the absolute value. Assume that x is positive. Okay. So move this negative up. It's going to be ln of x to the -1, which is ln of 1 over x. Okay, bring it into the integrating factor formula. So the mu is e to the integral of the px dx. So this is going to be e to the ln of 1 over x, which is 1 over x. So your integrating factor is 1 over x. So now we are ready to find the solution, but remember the variable is z. So the solution would be z equal to 1 over mu integral of qx times mu dx. Okay. Now substitute. So this is going to be 1 over x. Okay, it's going to be 1 over x. The integral of qx is a negative x times mu, which is 1 over mu dx. Okay, sorry, 1 over x. Okay, mu is 1 over x. So the x and x will disappear. You use the reciprocal. So that gives you x, negative x. It's going to be negative x integral of the dx. Integral of the dx is going to be just x plus c. So z is equal to, okay, z is equal to the negative x times x, okay, times x plus c. And you multiply it, so that gives you negative x squared minus cx. So that would be z. Z is a negative x squared minus cx. Any question? You're not done. You have to substitute z. Remember the z for this problem, z was y to the -1. Okay, so z is equal to the y to the -1. So this is going to be the final answer. Y to the -1 is equal to the negative x squared minus cx. Change it to the positive power. So y over 1 over negative x squared minus cx. Okay, so this is how you take care of this Bernoulli type equation. Question? I'm going to give another one. So it's it's very easy to identify, and most of the time it's a straightforward problem. Okay. This next one we have some other algebraic points that we have to consider. Okay. So you have to show all your work. There's nothing to memorize. Change it to the linear equation example of z yourself and just go. Okay, so let's have another one. You have some nice one. One of them. And we are going to check the solutions. Okay, on Thursday. So let's check this. It's a y prime minus 1 plus x over x, y. And this is equal to the y squared. See this equation? Again, the term to the left is linear. Okay, but the term to the right, the q of x is 1. Q of x is 1, but there is a y squared. So it's a Bernoulli equation. Okay, so what you have to do is you have to get rid of these. Okay, so solution. So I'm going to multiply by y to the -2. Quickly, I simplified at the same time. So it's going to be y to the -2 y prime minus 1 plus x over x. This would be y to the -1. like the previous one that we did, and this is one. So this is going to be your z. Same thing that we did. Okay, so the substitution z is y to the negative 1. We need to find the z prime. Chain rule, negative y to the negative 2 y prime. You have to multiply by negative 1 to get this y to the negative 2 y prime, which is a negative c prime. Go back, substitute, write the equation in terms of the c. The point about this problem is when you go to that integral of a dx dx, I want to see how you handle that one. Okay, so this equation now would be changed. Okay, would be changing to get the negative c prime minus 1 plus x over x z equal to 1. Want to change it to the linear equation in terms of the c, you have to get rid of this negative sign. So multiply by negative 1, multiply by negative 1, your equation would be z prime plus 1 over plus x over x z equal to the negative 1. So this is a linear equation. Okay, it's a linear equation in terms of the c with the px. Okay, so it's linear. It is linear with your p of x is 1 plus x over x, and the q of x of a negative 1. So you have to find the integrating factor. U. Now you have to find the integral of px dx. Okay, integral of px dx, which is going to be integral of 1 plus x over x dx. How are we going to find this integral? Any suggestion? See it? Break it. Break it into the 1 over x over x, which is 1. Okay, so you break it into the 1 over x plus x over x dx. So it's going to be 1 over x. Okay, 1 over x plus 1 dx. You know, integrate it. You got the first one would be ln x, you got the second one would be x. No constant c because we just find the integrating factor. So this is going to be ln x plus x. Okay, assume that x is positive, you don't need that absolute value. Now bring it to get the mu integrating factor. So it's going to be an integrating factor. Mu is equal to the e to the integral of the px dx. Substitute. So if you substitute, that give you ln x plus x. You want to simplify this one? Any suggestion? I'm going to simplify it. Again, we break it. We break it into the e to the ln x times it by e to the x. But e to the ln x would be x. So that give you x e to the x. Okay, so that would be our integrating factor. This is coming, you know, in different places, even in future. Something like, you know, 1 over x plus x. Okay, now we are ready to find the z. Remember, find the z first, and then change it to the 1. So finding the z. So the z is going to be equal to the 1 over mu integral of qx times the mu dx. We substitute 1 over mu. Mu is x e to the x integral of qx. Qx, remember, it was 1. Negative 1, yes. It's a negative 1 times a mu. And the mu is x e to the x dx. Okay, we can pull out the negative sign, but we have to use the integration by parts. That would be -1 x e to the x integral of x e to the x dx. Now, we can use the table, or this is easy to find. Okay, so integral of x e to the x dx is going to be what? I think it's x e to the x minus e to the x. Maybe I give you the result like. Okay. So that is the case that you have is a positive x e to the x. And this would be 1 x again, and this would be 0. So this is going to be your x e to the x minus e to the x plus. If you're not done, we have to bring it here, simplify it a little bit, and substitute for the y. Okay, so z so far. Z is equal to -1 over x e to the x times it by x e to the x minus e to the x plus c. Multiply inside, simplify it a little bit. If you multiply inside, these two will cancel out, so that give you a -1. For the second one, e to the x would be canceled out, so that give you plus 1 over x. And for the last one is as is, cx e to the x. So that would be c. And we claim that the z is equal to the y to the -1. So y to the -1 now is going to be -1 plus 1 over x. And c x e to the x. If you want to switch it, it's going to be y equal to 1 divided by whatever we have. So that will be the result of the Bernoulli equation. Okay, so we talk about it now because it's related to the linear equation. But the Riccati one, we talk about it later on. That one would be much more. Okay, so we are done with the linear equation. So expect 2 questions from the linear quiz. One straightforward linear equation, the other one Bernoulli equation. Yes.
How many questions are on the quiz?
6. There are 6 questions, you answer 5. On the test, 11.
And it's in person.
Hmm?
And it's in person.
Everything in person. Yeah, because the course is in person, so.
Did we get a note sheet on the quiz, like the test?
Yes, I thought, you talked about the other day. You need 1 page. You get quite a lot of formulas. Quite a lot. Yes,
How much time do we get on the quiz?
quite a lot. At most 1 hour. But this first one can be done in 45 minutes, 40 minutes. There are some that you need more time. We give you an hour. We want to test everything on the quiz. So there are going to be a situation when we get to the Laplace transform, it takes time. But there is a lecture, you see, half an hour. We give you a lecture. We need to have a short lecture on the day of the quiz, but on the day of the test, you need that 2 hours to do it. So this is everything. Yes,
Will the lecture be before or after the quiz?
yes.
Will the lecture be before or after the quiz?
Which one is better? Oh, it's going to be after. After. The quiz first. Okay, so let's go. So this is going to be Bernoulli.
Yeah.
Okay, any question? Now,
Yes.
so far you have one separable variable if you like, okay? We talked about the other day, separable variable, and we talk about the linear, and then we talk about the Bernoulli equation. You need 3 more, okay? Officially make it 6. Now, all the 3 are coming from this section. This is a very interesting section. It's the kind of things that we do in calculus 3. The conservative force. If you remember, you see you have a function of 2 variables. In those cases, we have potential function and the vector field, we connect them together. if we have a case that the differential of a function happened to be zero, that would be that then we can use the fundamental calculus. It's very similar, but we have to modify it in the format of a linear equation. So I'm assuming that how many of you have done calculus 3? Okay, so it should be fine. Okay, the thing that we need, so I give you a couple of examples just to tell you what is happening to that one. You just review, you need only 2 things really. I can review that one. The notion of the partial derivatives is the one that we need. Okay, I review, I just give you a couple of examples, just at this one, then I go to this. Okay, so this is 2.4. It's a 2.4 and the name is exact equation. Want to know what is exact equation? Okay, exact equation. I just review just a couple of terms from calculus that give you a better understanding of the subject. Okay, so let's do that review first. We say we are going to consider a function of 2 variables. So we can differentiate it. If you want to differentiate a function of 2 variables, you can freeze one variable as a constant and differentiate respect to the other one. If you do this one, the result is partial derivatives. So we can have partial derivative respect to the x or partial derivative respect to the y. So I just do that one first. Recall that if z equal to the f of x comma y is a function of 2 variables. 2 variables, then the partial derivatives. The partial derivatives. Partial derivatives of f with respect to the x and y are going to be denoted by, this is a notation that we're going to use. We don't use this is call it rho. It's like you talk about the df dx or dy dx for the y prime, and this is going to be the partial one. This means derivative of f respect to the x. This is one way to write it down. And the other way that we write it down in short form is f sub x. So this means the partial derivative. This means you keep the y as a constant, you differentiate respect to the x. Okay, so that's going to be the one, and this is respect to the x, and then respect to the y. Okay, rho f rho y is going to be f sub y. This is going to be the partial derivatives. So, for example, if f of x comma y is going to be equal to the x cubed, that's 5x squared y cubed minus 2y squared, then see, we want to differentiate respect to the x and respect to the y. So let's see what's going to be derivative respect to the respect to the x, for example. What is going to be round f round x? You see, we get to the first one. X cubed, derivative of x cubed is 3x squared. 3x squared. We get to the second one, y is a constant. Y is like a 5. You know that if you have a constant coefficient, when you differentiate it, the constant coefficient stay as is. So again, we focus on the x squared. The derivative of x squared will be 2x. So 2 times 5, 10. That give you 10x. That constant coefficient would be repeated. Then x y cubed. Then we get to 2y squared. Derivative of y, since y is a constant, respect to the x would be 0. So that would be derivative respect to the x. So if the variable is isolated, the derivative is 0. If the variable is a factor, the variable will stay as is. So that would derivative respect to the x. Now derivative respect to the y. Now you keep the x to be constant. So if x is isolated, derivative is 0. If the x is as a factor, it stay as a factor. Okay, the derivative of x cubed would be 0. With respect to the y, you focus on this one. 3 times 5, 15. 15 x squared as is, but y squared. With respect to the y, minus 4y. So that gives you the partial derivatives of these functions that we mentioned. Okay, any question? Let's give you more example when we go on. This is one that we need. The other thing that we need is the differential of a function. You have a derivative of the function, then you have a differential of the function. If you have a function of one variable, you see y equal to the f of x, differential of the f. What is differential of the f? Differential of the f would be f prime of x times dx. So if you, again, so I just recall that if y is equal to the f of x, then differential. Okay, differential of y, okay, is denoted by dy, or just you can say df. df, differential of y, differential of f, and is defined by what? Differential of the y. It's just f prime of x times the dx. Say f prime of x by itself is going to just the derivative, but the differential, you multiply the differential of the x. And you know that even in calculus 1, dy equal to f prime x dx, we call it the differential equation. Because you have the differential of the x, which is the dx, differential of the y, which is the dy. That is going to be a situation I'm going to have, okay? Now, if you have a function of 2 variables, you get this differential, we can use a kind of a chain rule. Instead of derivative respect to the x, f prime of x with derivative respect to the x. But you see, now if z is equal to the f of x comma y, now a function of 2 variables, then differential. Okay, that's it, the differential of z is given by, you see, this is differential of this. Do as we did over here, it's going to be derivative times the differential. But the function is a function of 2 variables. So the derivative that you can use is a partial derivative. So it's going to be partial derivative of f ln x times differential of the x. You see, times the x. Since it's a function of 2 variables, we continue plus differential of the f respect to the differential of the y times dy. See, that would be a kind of differential form for a function of 2 variables. You know that it's very easier to use differential for a function of several variables rather than the derivative of the function. Any question? Now this is the one that we need. This definition that you have over here. Okay, and you know that if you have a constant function, the derivative of a constant function is 0. On the other hand, if you have a function whose derivative is 0, that function is a constant function. You know that we can prove this one by the mean value theorem. So it would be the same thing here. Yes.
Isn't this similar to Green's theorem? Isn't this similar to Green's theorem? I swear I saw this at some point towards the end of calculus 3.
Calculus 3.
Right.
See this one quite a lot in calculus.
Okay, yeah.
Yeah, Green theory would be too much.
No, okay.
Yeah, this is just the beginning.
Right.
Okay, we don't go that far.
Well, I'm just saying because if you,
Yeah, the application is going to be eventually, can be used for Green's theory,
no,
but not now. Okay. Let me say the exact, then we get to that part. Okay, so for the time being, just staying with the derivative only. Okay. So this is that is the conclusion that we need. If a function is constant, derivative is zero. Derivative is zero, the function is constant. But in this case, instead of the derivative, we are going to use differential for the function of two variables or several variables. Now, what we are going to do quickly, the equation that we are interested in, you see, these are the function of x and the y. And this is differential of the x, and this is differential of the y. So this by itself is a differential equation. But especially if this dz is equal to the zero. If dz is equal to the zero, the result would be an equation. Okay, but since dz is equal to the zero, so this means z is a constant function. So we are going to consider the differential equation that would have this property. And this property is going to be, in those type of equation, are going to be called exact equation, if you like. Okay, in the case of calculus 3, if the vector field is going to be conservative, differential would be zero. So this equation would be zero. Then this f over here would be the potential function. Remember, if you have done calculus 3, then that potential function would help you, okay, to find the integral. You may use Green theorem, etc. Okay, so it's very much, we copy that one, but we stay with the menu of the course. Okay, so now having said that, we can now define what is the exact equation. Okay, so again, I start with that differential form that I have. Okay, so the definition, you can put it in this format. Now, suppose now we have a function of two variables officially with this condition. Okay, so suppose we have a function z is equal to the f of x comma y. It's a function of two variables, but for some purposes that some of you know it, we assume that the partial derivatives does exist, and also those partial derivatives are continuous. You know that if they are going to be continuous, when you want to differentiate, the order is not important. That's why. So suppose is a function is going to be a function. It's going to be a function with continuous first partial derivatives. Partial derivatives. So this means not only the partial first partial derivative exists, but also they are continuous function. Okay, you need this assumption for all the theorems for the function of server. If this is going to be the case, then the differential of the function, the differential of z, I just repeated, the differential or total differential, we calculate. Differential of f is defined by, the one that I created before. That's it. Differential of the f is partial of the f round x, times the differential of the f plus partial of the f respect to the y times the dy. That is differential of the f. Now, the one that we are going to be interested in when this is going to be a constant function. So note that, as I mentioned, if f is constant, if f of x comma y is equal to the c is a constant function, constant function. Then derivative of a constant function is 0. In this case, the differential of f would be 0. Okay, differential of f would be 0, and that equation would be what? See, this would be changed into the round f, round x, dx, plus a round f, a round y, dy would be 0. Okay, so if f is a constant, so we can have this differential equation. But the thing we are going to be interested in is going to be the converse. So conversely, okay, that's going to be conversely a differential equation. This is the part that we are interested in. A differential equation. Look at this differential equation. M of x comma y. It's a function. You go with the m and the n. Same notation that we use in calculus 3. dx plus n of x comma y dy equal to the 0. See, this differential equation is said to be exact. Said to be an exact, the name is exact. Okay, said to be exact equation if there is a function. If there is a function. Okay, if there is going to be a function of two variables, f of x comma y, such that the differential of the f, okay, derivative of f respect to the x would be equal to the m, and derivative of f respect to the y would be equal to m. Look at this one. So this equation is going to be called okay, exact equation. If you find you can find a function whose partial derivative is equal to m. This means you can find a function that satisfies this equation. If this function satisfies this equation, as I put it over there, in that case, the differential of the f would be 0. So in this case, the differential of the f would be 0, and you are going to have f of x comma y equal to the c. You see, this is going to be an equation in terms of the x and the y. Y is the unknown is in your differential equation. So in that case, automatically you get the solution of the differential equation. It's going to be the solution. Okay, the solution of the differential. Okay, differential equation. So that's a long way to define the exact, and we are going to put it into an easy format quickly. But this is going to be the idea. As I talk about it, we haven't done anything. It's just we have a vector field. We want to check if this vector field is going to be okay conservative. If it's going to be conservative, you must find a potential function. The potential function is exactly what you did over here. So since you don't have, these are the expression from calculus 3, but we don't know it. So we just put it in the abstract format. We said they are going to be satisfied this equation. Of course, this condition is not easy to handle. So if a differential equation is given to you, you want to prove that this equation is exact, you're going and find this f. So if you are lucky and the equation is already exact, yes, you get it. But sometimes maybe the equation is not exact, and you spend so much time in order to find this function f, then it won't be possible. So what we're going to do, we are going to find a shortcut, if you like. We're going to find a formula that enables us to check if this equation is going to be exact right at the beginning. So what's going to be that one? This is it. You see, this is called the partial derivative with respect to the x, the first partial derivative. and this is respect to the y. You see, when you differentiate respect to the x, this new function is a function of two variables. You can differentiate with respect to the y, or you can differentiate with respect to the x again. You see, we find this derivative, we continue, we differentiate this one again. So you differentiate respect to the x first, then the y. Then we go to the other side. This is derivative respect to the y. We differentiate respect to the x. So you have a function that you differentiated twice with two different orders. The first one is differential respect to the x, then y. The other one is y and x. There is a great theorem in calculus 3 that if you have a function with a continuous partial derivatives, if you want to find the second derivative, the order is not important. So that will help us to find a condition to check to see if the given equation is going to be exact. Okay, I just want to give you, I didn't want to just start writing that condition on, okay, just give an idea that you already done calculus 3, you know better what we are talking about, or otherwise you understand a little bit, okay? So I give you this famous theorem, and then I take it as a definition of the, solving that equation is easy, but creating this condition is important, okay? So this is a famous theorem in calculus 3. Borrow from here. Borrow it, and will help us to know is it a differential equation. A differential equation of this form. M of x comma y. That's n, I'm sorry, that must be dx. Dx, this is x. That's n of x comma y, y equal to the 0. This is exact with the condition that we talk about it, if and only if this condition satisfied. The partial of m respect to the partial of y is equal to the partial of n respect to the partial of x. That's it. Or in short, my is equal to the nx. See, that is going to be the condition that we can, we can have. So a differential equation is exact if it's satisfied, okay, satisfy this condition. If you want a proof, I can give you a proof. Okay, let's prove it. Tools to be able to prove it from this side. Suppose it's already exact. Let's use the definition of the exact. See, suppose this equation mdx plus ndy equal to the 0 is exact. What does it mean? Remember, it's going to be exact if you find that function. Then there is a function. The definition that I give you, a function f such that the function of f such that round x is equal to the n, and round y is equal to. That's the definition that we give you. From this part, you differentiate respect to the y. So it's going to be second derivative of f, respect to the y first, then respect to the x, and that will be the derivative of m, respect to the y. Differentiate this part, respect to the x. So second derivative of f, respect to the x, respect to the y is going to be the derivative of n, respect to the x. Order of the, okay, order of differentiation. But as I talk about it in calculus 3, we prove that these two are the same. So it doesn't matter You derivative, you differential respect to the x, then y. Or differential respect to the y, then x. So this means the second part must be the same. Round m, round y. Okay, is going to be equal to the round n. That's it. Or my is equal to the n. So that gives you something that you can check right away. So we are going to take this one as a as a definition that we have. So a differential equation will be given to you. You want to check to see if it's exact. So what you have to do, you take the coefficient of the dx to be n, the coefficient of the y to be n. You find the derivative of m respect to the y, then derivative of n respect to the x. If they are the same, the equation is exact. Otherwise, if it's going to be the same, then you are going to use this idea to. I give you a break. Have your break, we come back and do it. Okay, the procedure of the solution is much easier than. Of this equation. Okay, so this is how the question will be given. You ask me to determine if the equation is exact. If it is, solve it. Okay, so this is it, determine. Okay, determine if which equation is going to be exact. If so, your answer is yes. Find the solution. Okay, find the solution of the equation. Differential equation. See it? First one. This one, sine x, tan y plus 1 dx. All of them would be given to a differential. And the second one is cosine x, secant square of y, dy equal to this. That's a given equation.
Is it secant squared y dy?
That's it, secant square of y, secant square of y dy. Yes, thank you. Okay, secant square of y dy. Yes. Okay, you identify m and n. M is the coefficient of the dx. N is the coefficient of the factor. Okay, so this is going to be m, and this is going to be n. Okay, so this is going to be the solution. Just repeat it again. This is m, which is a sine x, a tangent of y. So what? In the case of the m, you differentiate respect to the y. M is coming with the dx, but you differentiate respect to the y. So we find my. That's easier to write down. Derivative respect to the y. X is going to be constant, you see. So we differentiate tangent of y. Derivative of tangent y would be secant square of y. Sine x is as a coefficient, stay as is. So it's going to be sine x secant square of y. This is going to be derivative with respect to the y. Any question? So if the x is isolated, the derivative is 0. If it's not, you differentiate. It's going to be just stay at it. Yes.
Yeah, you wrote secant twice.
Oh, that's a sine. Sorry. That's a sine x. Okay, that's a sine x. Okay, so it's a sine x secant square of. That is going to be the derivative of m respect to the y. In the case of the n, you differentiate respect to the x. N equal to the cosine of x secant square of y. You differentiate respect to the x. Y is a constant. You differentiate cosine. It's a negative sign. and that's the coefficient, it stays as is. So it's a negative sine x secant square of 1. As you can see, they are not equal to each other. So m sub y is not equal to the n sub x, and the equation is not exact. Okay, it's not exact. And this is done because it's not exact. Any question? So be careful, those signs are important. Ready for the next one? So the second one. With this one. Equation is 2xy squared. That's 2y dx plus 2x squared y plus 2x dy equal to the 0. Coefficient of the x would be m. So this is going to be your m. This is going to be your n. Okay. Start with the m, which is a 2xy squared plus 2y. Differentiate respect to the y. X is a constant. So we're differentiating 2y squared would be 4y, but 4xy. 4xy. And the second one, differentiate respect to the y, the derivative of 2y is 2. So that gives you 2. Any question? The differentiate respect to the x, if it's a factor, it stay as is because it's a constant. If it's isolated, derivative would be 0. Take n. Okay, n. Our n is 2x squared, and I repeat all of them, you can do it right away. So now we differentiate respect to the x. Differentiate 2x squared respect to the x will be 4x, but it's the 4xy. 4xy plus the derivative of x respect to the x would be 2. So they are equal to each other. So my equal to the nx, and the equation is exact. Okay, it is exact. Okay, since it's exact, you have to solve it. Now, how can you solve it? Remember, you need a function. You need a function to function f such that, let me just explain it for you. You see, this is the solution. 1 or v. 1 should find a function. Okay, a function of two variables, f of x comma y, such that this function would satisfy two equations. The equations are round m, round x is equal to the m. Okay, that is going to be the first one. And we have the m. M is 2xy squared plus 2y. And the round f, round y is equal to the n. N is 4xy plus 2. Remember, if you find this function, you just replace this function. So this differential equation will be differential of your function, which is 0. And you let f of xy equal to the c as a constant, and that gives you the solution of the differential equation. So you have to find a function f that satisfies this condition. When you find it, differential of this function is 0, so f of xy equal to the c will give you the final answer. Okay. Now you see this is a kind of a system of differential equation. I call this one 1 and 2. It's like f prime is given to you, you want to find the f. So you have to integrate it. You have to integrate, but you got to be careful because, okay, you have a function of two variables. Yes.
Can you explain how come for n you did the 2xy squared plus 2y, but then for n you did the differentiation in terms of x?
No, you see this first one is called M.
Mhm.
The second one is called N,
Yeah,
okay?
but for n, when you wrote it down below, you did 4xy plus 2.
You wrote the partial.
Yeah, you wrote the
Yeah, look
partial
down
for n and the not partial for n.
in red.
Oh, this one?
Yes.
Oh, I'm sorry. Yes. I made a mistake. Thank you. So this means N. I made a mistake here. Thank you. So it's a 2x squared plus 2x. Very good.
Hmm.
Okay, now this is a system of differential equation that you have to solve. So what you do, you just integrate it. You may take the first one. If you take the first one, in order to find the f, you have to integrate respect to the x, okay? The partial integration. If you take the second one, you have to differentiate respect to the one. Sometimes one of them may be easier than the other one, or sometimes it doesn't matter. But the point is, if you pick the first one, you're integrating respect to the x, so y is constant. When you integrate, you usually add last constant c. But in this case, since the y is the constant, so your constant is not going to be constant c. That may be c of y. So that constant may be a function of y. So we don't usually like plus c, we like plus g of y. Then you have to find the g of y. How are we going to find the g of y? You use the second part. Because the second part gives you derivative with respect to the y, and you check to see if this new function is something. If you start with the second one, you are going to integrate respect to the y, x is the constant. So your constant would be not c. It's going to be a function of x. We call it g of x. Then you have to form the first one to find out whether g of x is going to be something. Okay? So this is going to be the procedure that we have. In this case, both of them are easy, so it doesn't matter. So I'm going to start with the first one, okay? So start with the first one. So integrate respect to the x. So again, it doesn't matter. You can use either one. So what I'm going to do, I'm going to start with the number one. So I'm going to integrate. If I integrate the left, that gives me f of x comma y. I'm going to have the partial integration for the first part respect to the x. And the first part was 2x y squared, okay, plus 2y. But I'm integrating this one respect to the x. Integrate respect to the x. Again, the y is constant. So integral of 2x would be, okay, x squared. Okay. So this is going to be x squared, y squared. Integrating 2y respect to the x, that give you 2xy. But there is a constant. That constant, since you integrate respect to the x, the constant can be a function of y. This is the way we write it down. You can write c of y if you like. And we usually go with the g. Okay, I just repeat it again. So integrate respect to the x, that give it 2x squared divided by 2. 2x squared divided by 2, that give x squared y squared. Integrate 2y respect to the x, that give it 2xy. But you may have a constant, that constant. So, so far, this is what we have. We have f of xy is equal to the x squared y squared plus 2xy plus gy. So you have to check to see what is gy. Okay, I usually call this equation number 3. Now, in order to do it, I'm going to use the second one. In the second one, you have the function, derivative of the function with respect to the y. So differentiate this one with respect to the y first, then compare it with the number 2. So that would be the next step, differentiate with respect to the y. What is going to be round f round y? With respect to the y, derivative would be 2y, so 2x squared y. With respect to the y, derivative would be 2x. And derivative of g would be g prime of y. But remember from the second equation, you already got the round f round y. In the second equation, round f round y was, what is the second one? It's a 2x squared y plus 2x. Now let them to be equal to each other, or compare them together. Okay, if you let them to be equal to each other, these two would cancel out, these two would cancel out. So the leftover is going to be G prime. So G prime of Y would be equal to this. Okay, because this is 0 part. Any question? So when you let them equal to each other, you drop them down to get these numbers. Okay, that giving yes. Don't do it. I know what you're talking about. Okay, what's the question?
Can we, for M and N, can we do the partial integrations of both and just see if there's anything
Don't
left?
do it.
No.
Yeah, mathematically, you get the same. Yeah, the other method that then the people that do it, they integrate both of them. The first one with respect to the X, the second one with respect to the Y. Then they drop the equal terms. The leftover is going to be your function that you are going to be. It's going to be the same thing. Okay, that's a lazy one. Okay, you don't mind. Mathematically, doesn't make sense. Okay, but it's not a big deal. Okay, so we prefer this one, G prime of Y. So G of Y would be a constant, which is nothing extra for you. Okay, so you go back to this. Okay, and so f of x y equal to the x squared y squared plus 2xy. If it's a constant, even you can drop it. You can leave it. It's not going to be, but I'm going to write it down for you. So this is going to be f of xy. But remember the solution to the equation. This function, as I prove it for you, this is a function that the differential of this function is 0. So the function must be a constant function. So this is the way you have to find. You are not done. So the solution of the equation, you see, the solution of the equation is you let f of xy to be equal to the constant. Okay, you can call this one C1 if you like. You don't need it. If it's going to be constant, we are going to ignore it even. Okay, because eventually we let f of xy equal to the c because the differential is here. The solution of the equation is this one. So that's going to be x squared y squared plus 2xy equal to the c. Y is the solution of the equation, but we cannot find it. So we give you the solution of the equation in implicit form. There is a y here. Go and find it. Okay, so this is how we end up there, the end of the problem. So it's very straightforward. The problem that we have, you have to check the g prime. If it's going to be equal to the g prime of 2y squared, then you integrate it to get the g of 1. But in this case, it's happened to be equal to the constant. So we already proved that this f, that this is a potential function, if you like, in calculus 3. Okay, so we know that the differential of this function is 0, so this function is a constant function. So we let it equal to constant c, and we propose the solution. We propose the solution, of course, in kind of implicit form, not a direct one. So this is going to be a type 1. If you just give me a couple of minutes, I can give you one more quickly. Or okay, I won't get time. So I talk about in there. So this is going to be. We have only one more step. We check to see if we can do that one as well on Thursday. The next question is going to be: what would happen if this equation is not exact? Then you do something about it. There are possibilities that sometimes you can do. You can multiply by something nice, like the linear equation that we do, to make it. One example. We cover that. So I have the solution of the practice quiz. I will post it. I will go over it. So, so your quiz will be after the end of this section.
Get a little snack. Do you know what that is?
Thank you, Professor.
Why not? We had lunch at like 10 a.m. Nice snack.